Afternoon, everybody. Hopefully you're not all too tired to scrape through this one. Mike asked me if I could do a talk today, and I tried to decide what I was going to do it on. For those of you who see me outside, I've got the LED screen. I've made robots, I've used the Pi, I've used the Arduino, I've used all sorts of different things. And I've been programming now for just over 30 years, which is a bit scary. And when thinking about this, I thought back to a conversation that I had a few weeks ago with one of my colleagues in Makespace in Cambridge about programming in C. There's lots of things out there these days. There's lots of books. There's obviously the stuff that's been in the Raspberry Pi Mag recently. There's the Pi book, which is very good. But people are still saying, why would I use it? What's the point? It's too hard, it's too complicated. There's no point me doing it, or I can't get started. So I thought, right, let me see if I can try and do something in half an hour that'll open your eyes a bit, open your minds a bit, maybe help you move forward with C. You might still decide you don't need it. There are so many languages out there these days, why do you actually need it? But hopefully this will help you get started if you want to. First of all, before we do start, are there any C programmers in the room? I know there's one because I met him at the cafe earlier. Excellent. Python? Scratch? Okay, so a few different things. Java? Anybody not done any programming at all? Okay, cool. So everybody's done something. Now the thing for me with C is it was one of the early ones. It started a lot of things. So there are a lot of things these days that are based around C, so it's a good foundation for you to start from. And understanding the structures within C, understanding the logic, understanding how to read it, will hopefully help almost understand, for me, how other languages have come about. So why did I call it Learning to C? Because actually, I see it as learning to C. So this is what I think I can give you in half an hour that the books don't. I once said to somebody, I'd been coding for probably 10 years, most of that C and C++, and I said to somebody I could look at code. I didn't need to read code. I didn't feel I needed to read code to understand what it did. I could just look at code and understand what it did. He thought I was being facetious. He took the mickey out of me, but actually, after a while, he came back and said, okay, I kind of get that now. And for me, I got to the point I was using it so often that it did feel like I didn't need to look. I could actually just almost absorb it. And yet people are saying it's complicated. So there's lots of languages. Why C? As I said, it's the foundation of many things. So all of those things started off in C. Now some of them have moved on, but the operating systems themselves, largely written in C. Interpreters, compilers, largely written in C. Java compilers these days, potentially written in Java, but actually they all started off as C. And a lot of these languages were written by people who could program in C, so a lot of the structures are based on the paradigm that C is based on. It's fast. If you need something, so the reason that I ended up using C for the, that's me doing my teapot impression, using C for the screen, the technology that I used there has got examples in all sorts of different languages. So it's got examples in Python, it's got Java, it's got Perl, it's got processing, but the C stuff is quick. And once you've built a binary in C, you can just copy it about the place on the same platform and just run it. It's also got, I've skipped on, but it's got very few keywords. There's only about 20 keywords in C, so there's not a lot to learn. The biggest thing about it are the libraries. So one of the things that comes out is that it's complicated. You have to write a lot of code. You do until you start learning about the libraries, and then you can reuse a lot of code that other people have already written. So with Unix being written in C, with Linux being written, a lot of the binaries there have already got libraries with them that you can reuse. So if we look at the basic process, We start off with a source file, or set of source files. We compile them into a binary format, because obviously the machine itself is only going to use binary. Gives us a set of object files. Now potentially that's sufficient to run what we need, but actually we can combine that with some more object files that are collated into libraries. We link those together and we end up with an executable, and that's what we're going to be, that's what we're running on the as the end product of our work. Now I'm not going to go through that process, I'm not going to go through setting up compilers, any of that. You can get that from countless places on the web, including the books that are here. But what I want to do is to actually go through some code. So typically, this is your starting program, a typical hello world. And it's just code, it's just text, there's no colours. That I didn't bother using a colour highlighter, syntax highlighter, an editor for this. That's what your basic program to print out the text, hello world, on the screen would look like. The advantage to me in C is that it doesn't care about white space. So if you want to structure it like that, you can. If you want to structure it like that, you also can. I would suggest you wouldn't want to, because it's not actually that reasonable. But I struggle with Python because it forces me into a structure. With C, as long as you've got your brackets in the right place, and as long as you've got the semicolons and effectively the punctuation in the right place, you can structure it any way you want. So you can make it readable to you. I would suggest that you actually want to make it readable to you and others, because you want to be sharing this code, you want to be reusing it as much as possible. If we move up from that to a slightly more complex example, you can make a real mess with C. And even that isn't actually very complicated. So if we put some decent white space in there, that's exactly the same code, but just done in a neat way. Got no idea if this is going to take half an hour, so I'm just going to keep going and we'll do questions at the end. So the feedback that I had, it's complicated, it's hard to read, difficult to understand. Because of that, you can make mistakes easily. Debugging those is a nightmare, and you need to write a lot of code. And if you've structured your code that way, I agree with quite a lot of those terms. However, let's look at something easier. So there's an easier example. And I know that repeat loop's irrelevant, but it's there for a reason. So that's just Scratch. So for me, that's dead simple to understand. On a click, you do that loop, you only do it once, so it says, say hello world. Well actually, if we go back to this example, and just put some colours in, it's pretty much the same thing. And having thought about it, that's what I do. Not necessarily the colours, but that's how I look at the structure. When I look at a C program, that's what I see. So if you understand Scratch and the logic there, and you structure your code in the right way, then it becomes dead easy to interpret the code, to understand the code, to see the code. Does that make sense? Cool. Excellent, okay, it is working. So if we go back to the more complex example, let's look at what we've got. So we've got a couple of main blocks there. Oops, that wasn't supposed to happen. Maybe it was. Right, okay. So we've got a couple of main blocks there. We can actually colour that in the same way. There's a bit of poetic license going on here, I'll admit that. So apologies to the Scratch or C experts. But they're fairly close in terms of the colours, in terms of the areas of code that I'm looking at here. If we break that down, so we can break that down into various different things. We've got blocks of code, we've got a function there, we've got we've got a conditional test, we've got variables used, we're doing displays. I've put a function in to display that text. Again, it's a fairly mundane example. You possibly wouldn't want to do it in that way. You would just call the print function directly. But again, what I'm trying to show is the structure and the way that these pieces fit together. So let's look at some more. So let's look at some of those details. Some main components. I am, again, in half an hour, I'm not going to teach you C, but I'm going to go through some of the main bits, hopefully, so that you can understand how they fit together, their importance, and again, how to see them when you look at a code, and ideally how you should be structuring them to make them easy to use for yourself and everybody else. So let's have a look at functions first. So we've actually got two functions in the example. Main is the core of your C program. So in building up that executable, the main function is what's called. So there's always a wrapper built to contain an executable. So an executable is a wrapper with your code within it. The wrapper is relevant to the operating system you're on, and it will then call the main function in your program. So there'll always be a main, and that's always your starting point. Now I've put in there a display text function, and it's called from main. So the calls to it are the purple elements, and then at the top there, the display text makes a call out to printf. The order is important in this case. So you need to declare something before you use it. The compiler, when it's looking through, will start at the top of a source file and read its way down. So either you need to put your function at the top like that, or if you've structured it, you've got a lot of code and you've structured it in separate files, then your function needs to be declared in an include file, which is included at the top. Very similar to the way you would import from Python, for example. So those are the two orange blocks of the two functions. And then the calls to the functions, as I said, the purple pieces. As the words say, if you've got a simple program, you can put it all in one file. If it's more complicated than that, then structure it logically, structure it sensibly. If you've got a bunch of functions that do display, then put them in display.c. If you've got something else that writes to disk or writes input-output, then maybe it's in something io.c. Make it dead easy for you, because at the time that'll make it quicker to do, and later on when you come back to it, it'll be obvious. Obvious is good in this case. Clever's nice, but obvious is better to my mind. It makes it a lot easier to share, makes it a lot easier to reuse, and in a world where we're not doing this all the time, and we're going back to school and back to work and back to college and then coming back to this, if you've made it easy, it's going to be easier to get back into when you come back to do it. Curly braces. Probably shouldn't call them curly braces, probably curly brackets or whatever. I've always called them curly braces, and they're key. So white space isn't important, but curly braces really are, because they, in C, provide the structure that the compiler understands, where in Python it forces you to put in tabs. So in Python, if you've got those blank lines, they would be important. C doesn't really care, because it just cares about the curly braces. So there's three code blocks on the right hand side. There's the block within the function, and then there's the block within the if statement there as a separate block. That probably should have been two, but it fits better with the Scratch comparison to do it as one. Variables. So I've only used one here, and again, looking through the C book to do a bit of revision, because I haven't used C for a while, but looking through that, there are different types. You must declare variables before they're used. Some people dislike that because they prefer to use a language where you can just use something. But for me, it helps me to think about what I'm going to do and what I'm going to do with data. If I have to think up front, okay, I'm going to need this, I'm going to need that, I'm going to need an X coordinate, a Y coordinate, I'm going to need a colour, for example. I'm going to need a flag here in this case. That could have been a Boolean, but int's a typical example at the start of every book, so I figured I'd just use an int in my example as well. There's lots of different variable types. It's good to understand what those types are and what they can and can't be used for before you start. So definitely a key thing to look at. You can pass them as parameters into functions. Give them meaningful names. If you're going to pass them as a parameter, then what does it mean when you're passing it in? Also, be careful when you're naming things. One thing I've not mentioned on here is global variables. Because as a C programmer, as a young C programmer, I was always taught never to use them. The danger with using, the great thing about globals is you can access them from anywhere. From any piece of code you can refer to a global variable, which is great because it's really flexible. You don't have to declare them more than once. But it's also bad because everything then refers to the same thing. So it gets really confusing when you've got 3 different functions referring to the same variable. Is it the one that's global? Is it the one that's local? It all gets a bit confused. So structure your data ahead of time. I always kind of put these things in first. I would start a program with some comments, and then I would add the variables in so that I know what data I've got, and then I'd add the functions in to handle that data and do the work that I wanted to do within the code. If there are any questions, I didn't say this at the start, if there are any questions, please ask on the way through. But the way we're going, there's going to be plenty of time at the end. Operators. Again, what am I going to do in this session that you're not going to get anywhere else? So I didn't want to run through all of them. It's the logical ones that you're going to get. There's ands, there's ors, there's equals, there's not equals, greater than, less than, all of those things. But the key one here in C, for me, is equals, and the fact that equals is not the same as double equals. So I've tried to write it out there, hopefully that makes sense. One is an assignment, the other is a comparison. So in the case of the orange section there where you're doing the assignment, you're setting int, that integer, that in space integer to be 1. You're actually putting that value of 1 into that variable. Within the green piece, you're comparing what's in that variable to the value of 1. If I'd have just put a single equals in there, that would always be true, because if you do an assignment, it's always true no matter what. But it's a very, very common mistake to misuse, typically to put in a single equals in an if statement. And you spend ages going through it, because it looks right, but because there's only one character missing. So does that help? Does that help C? To me, it is the summary. It is the foundation. It's great to have. Somebody said to me earlier, well, I've tried C. I didn't really like it. I didn't really get on with it. I don't see the point these days because I can do everything I need to do in Python. Fine. There's no pressure to do this. There's no need to learn C if you don't want to. As a teenager going through sixth form, somebody said to my mum, if he's going to learn programming, he ought to learn C. And for me, it's been fantastic because it's made everything else easy. Because it's got so few keywords, because it's got that those rules around structure that you need to enforce yourself. You need to declare the variables first. You need to, before you use them, you need to declare functions before you use them. There's an element of structure there that forces you to control the way you do things yourself. If you do write code in a structured way, it's easier to read and you can just absorb it. And for me, it can be seen. These days, you don't need to write everything yourself. You really just need to, you can if you're interested, but you really are providing the glue between everything else that's out there. But in doing that, and when sharing that, try to make it easy, both for yourself and others, when they're going to be reusing your code or they're going to be sharing your code and potentially helping you with your code. Stick to the structure, make it look easy, make it obvious, and it's going to be easy for everybody. We've been through some of the key points, we've been through some of the key structures, the things that are going to catch you out. It is a very simplistic session today, hopefully that makes it easy. But again, hopefully I've covered enough to get you interested again if you looked at this and decided you weren't going to do it. Hopefully it isn't as hard as you thought it was. Finally, just a thought from somebody, again, that I worked with quite some years ago. And I'm not sure where I got the quote from, but I quite like it. So your code doesn't have to be beautiful, but if it's not right. If you make it beautiful and you make it clean, it just feels better. It's easier to use and it's easier to share. And that's what I've got. Hopefully that helps. Any questions? I'll take anything, whether I've talked about it or not. Sorry.
So what newer generation languages have you used after C? Because C is sort of fairly far back in the heritage.
So I started with C, I then moved to C++, I then did Perl, then Java. I've recently done Python, a bit of processing. I think that's about it. But it kind of, to me, it was almost, C was almost like learning English before then doing French and Spanish and German and Polish recently.
Have their heritage.
Right. Cool. Yep.
I would say there's two reasons for using C. The first one is if you're going to use an Arduino,
Yep.
C-like.
Yep.
I would say if you want to get away from the compilation side of it and all that setup, an Arduino is great to go by, but you should be picking a language that's right for the thing that you're actually doing.
Yeah, and in these in that yeah, and there's several different things to that. Is right to what you do. Do you need it to be fast? Do you need it to be low level? Do you need it to tie into the operating system? Whatever. But also, if there are masses of libraries in Python, then use, and you know Python, then use Python. I mean, even things PHP and that kind of stuff. You've got scripting languages like that. And it's kind of, it's pick the one that's going to get the problem solved the easiest, is for me the way to do it at the minute. Or just do everything in one, just do everything in the one that you know, because that's easy too. Anything else? Any other questions? Yep.
How significant is the differences?
Haven't seen you for ages, sorry. Oh, yeah.
Between C and C++?
How many differences? How significant? So I wouldn't say, so C++, anything you can do in C, you can do in C++. But C++ is a different way of thinking about things. So in C, you're having to take the real world and turn it into a set of functions, a set of a flow, a set of libraries potentially, and some code. With C++, what they tried to do was to enable you to more easily model things. So within C, you might have a chair.c, which has got all of the functions you can do to a chair. Whereas within C++, you've got a chair object, and you can do things to a chair object. So it's a different way of thinking about it. If you know C, C++ is dead simple. And if you know C++, you already know C because it's already included within it. Any other questions? I assume this is for the next one. Yep. Cool. I'll shut up then. Thanks, guys.